All right. So we'll be discussing about structural components of microprocessor and microcontroller. So at first, let's define what is a microprocessor. A microprocessor is a central processing unit or CPU on a single chip that performs general purpose processing tasks. It is the brain of a computer system, executing instructions, performing arithmetic and logic operations, and managing data flow. Microprocessors are commonly found in personal computers, servers, and other computing devices. As per the key features, microprocessor has three main features like the versatility, external components, and complexity. In terms of the versatility, microprocessors are designed for general purpose computing, enabling them to run a wide range of applications and tasks. They also require external components like memory, input and output interfaces, and peripherals to form a complete computer system. Kaya nga yung mga computers natin, di ba? So, may mga external components connected to the computer itself. Microprocessors are often more complex and have a higher processing power compared to microcontrollers. So ano naman yung microcontroller? By definition, a microcontroller is a compact integrated circuit that contains a processor core, memory, and peripherals all on a single chip. It is designed for specific control-oriented tasks in embedded systems such as managing electronic devices, appliances, and systems. Microcontrollers are commonly used in applications where real-time control and compact size are crucial. So ito naman yung mga key features ng microcontroller. So we have integration, task specific, reduce external components, and the low power consumption. In terms of the integration, microcontrollers integrate the CPU, memory, and various peripherals on a single chip, providing a compact solution for embedded systems. They are tailored for specific tasks or applications. So very specific talaga yung ginagawa ng microcontroller compared sa microprocessor kasi more of multi-purpose talaga yung microprocessor natin, such as managing sensors, controlling motors, or handling communication protocols. Kaya common kapag gumagawa tayo ng mga thesis, ang ginagamit talaga natin ay microcontroller, di ba? Reduce external components. So microcontrollers often require fewer external components compared to microprocessors, simplifying system design. So, hindi siya masyado nagre-require na marami external components connected to it, unlike for the microprocessor. At syempre, low power consumption. They are often designed to operate in power-constrained environments and are optimized for low power consumption. So, let's now proceed to the comparison. While microprocessors are designed for general-purpose computing and require external components, microcontrollers are task-specific, integrated solutions for embedded systems. Microcontrollers are commonly used in applications such as home automation, automotive systems, medical devices, and consumer electronics. Kaya, 'di ba yung mga thesis natin, most probably aligned din siya dun sa mga different example applications ng microcontroller stated here. In summary, microprocessors excel in general purpose computing while microcontrollers are specialized for specific control and embedded applications. Both microprocessors and microcontrollers have similar structural components, but they differ in their intended applications. Di ba kanina minention, may mga CPU sila, syempre may memory, may consumption ng power and stuff. So meron sila mga similarity in terms of structural components. In summary, while both microprocessors and microcontrollers share core components like CPU, arithmetic logic unit, which will be our first experiment, control unit, and registers, Pag sinabi nating registers, ito yung mga temporary storage ng data. Microcontrollers are designed for embedded systems, incorporating additional features on a single chip to simplify and optimize system design. So here, nagawa ko ng simple table para ma-distinguish natin yung advantages at disadvantages ng microcontroller at saka ng microprocessor reference to the different components. Kasi di ba sabi kanina, meron silang similar components or structure. Una, CPU. Microprocessor is, in terms of CPU, primarily ang purpose na ay for data processing. Yung microcontroller naman integrated with memory and peripherals in embedded systems. And then microprocessor performs arithmetic and logical operations. And then ganun din naman si microcontroller, executes arithmetic din and logical operations pero naka-embed siya in an embedded systems. Control unit manages data and instruction flow between components, and then si microcontroller naman coordinates operations within an embedded system. Registers holds general purpose and special purpose registers, and then microcontroller utilize registers for data storage, addressing, and control in embedded systems. Connected to external memory and peripherals yung microprocessor using buses kasi yung buses natin ay communication channel. Yun namang microcontroller integrates memory and peripherals on a single chip. In terms of the memory, microprocessor relies on external memory components, and yung microcontroller naman includes on-chip memory or the random access memory and the read-only memory. In terms of the other peripherals, microprocessor depends on external peripherals for specific functions, while microcontroller integrates various peripherals on the same chip. In terms of the advantages, ito yung mga advantages ng microprocessors and microcontroller and their disadvantages as well. High processing power si microprocessor, meron siyang versatility for various applications, suitable siya for complex tasks and multitasking. Microcontroller naman, integrated design for embedded systems, reduce external components and simpler yung design niya, and then lower power consumption specific applications. Disadvantage, syempre, si microprocessor, since high processing power siya, malaki rin yung consumption niya ng power. And then, external components required for full functionality and then larger footprint. So, medyo complex talaga kasi nga, yung mga tasks natin, mas madami kumpara sa microcontroller. Unlike for the microcontroller, limited yung processing power compared to microprocessors, may not be suitable for high-performance computing, and limited yung memory niya compared to external solutions. So again, meron silang kanya-kanyang advantages and disadvantages. Depende doon sa purpose, doon sa gagamitan natin, kung ano yung prefer natin, kung microprocessor ba or microcontroller. Para mas maintindihan natin, these are the different types of microprocessors. So, familiar tayo dito kasi yung mga laptops natin, mga PCs po natin, malamang ganito yung mga brands or yung mga microprocessors na meron tayo. We have the Intel x86, commonly used in personal computers known for high performance. ARM, which is also prevalent in mobile devices and embedded systems, efficient power usage. AMD Ryzen, competitor to Intel x86 known for offering strong performance. Yan, ito yung medyo common na ginagamit Intel and then the AMD Ryzen. Yung mga microcontrollers naman, we have different types as well. The Atmel AVR, widely used in hobbyist projects known for simplicity and low power consumption. The PIC or the Peripheral Interface Controller, developed by Microchip Technology, which is also popular in embedded systems. And of course, we have the STM32 or the ARM Cortex-M, powerful microcontrollers with a broad range of applications, and many more. There are a lot of types pa naman ng microprocessors and microcontrollers. So those are just the basic or the commonly used microprocessors and microcontrollers. So in choosing between a microprocessor and a microcontroller, the application's requirements, power constraints, and processing needs play a crucial role. So kailangan mong i-weigh in yun. Kailangan meron kang trade-offs. Ano ba yung mas prefer mo based on sa mga different criteria na na-mention natin. Ngayon, ito yung mga common question. Sir Caldo, what about Arduino? What about Python? What about FPGA board? Raspberry Pi? Anong category po ba ito nagpo-fall? Normal question to. Usually kapag nagdi-defense, nagti-thesis, hindi nila ma-distinguish saan ba nagpo-fall itong mga to. Yan. Una, Arduino. Tama po, Arduino, ang category niya ay microcontroller. Arduino boards are equipped with microcontrollers typically based on Atmel ABR or ARM architecture. They fall under the microcontroller category as they are designed for embedded systems, offering an integrated solution with input-output pins, onboard peripherals, and simplified programming interfaces. Kaya naman talaga naging commonly used ngayon yung Arduino kasi mas simple yung pagko-code niya, parang C lang siya or C++. Unlike kapag gamitin mo yung PIC, yung mga PIC microcontroller, mahirap talaga yung coding doon kasi assembly language yung ginagamit when you code using that microcontroller. So, clear tayo sa Arduino. Ano naman yung Python? Kapag narinig mo yung Python, hindi po siya microcontroller or hindi po siya microprocessor. It is a programming language. Python is a high-level programming language. It is not a microprocessor, microcontroller, or hardware platform on its own. Python can be used for a wide range of applications including software development, scripting, and data science. It is not directly associated with the hardware but can be used to program microcontrollers or interact with various hardware platforms. Again, pag narinig natin si Python, it is just a type of a programming language, specifically high-level programming language. Pag sinabi natin mga low-level programming language, ito na yung assembly language na pag-aaralan din natin sa subject natin. Pag sinabi natin na middle-level programming language, so pwede siya maging low-level, pwede siya maging high-level. Ang example nun, mga C or C++. And then of course, yung common na alam natin, yung mga high-level programming languages. Like nagja-Java tayo, 'di ba? So PHP, and then gumagamit din tayo ng mga VB.NET and so on. And then yung isa pa na pag-aaralan natin sa subject natin, hardware description language naman po yun. Yun yung Verilog, VHDL, System C, and many, many more. So ano naman yung FPGA board? Yan. Ito yung nakalinya tayo ngayon dito kasi nga doon na tayo sa makabagong panahon. Alangan naman gamitin pa rin natin yung Intel 8086. Siyempre, pag-aaralan lang natin yun pero hindi natin siya i-utilize. Iko-code lang natin yun ng content sa assembly language. Pero yung latest ngayon is the FPGA board. Pag sinabi nating FPGA board, Field Programmable Gate Array. Ang category ng FPGA board ay Configurable Logic. So, FPGA boards fall under the category of configurable logic devices. FPGAs are different from microprocessors and microcontrollers. They provide a hardware fabric that can be configured to implement custom digital logic circuits. They are highly versatile and find applications in digital signal processing, image processing, and other tasks requiring parallel processing. So, another question, ano naman po yung Raspberry Pi? Yan. Ang category talaga ni Raspberry Pi is SBC or the Single Board Computer. Raspberry Pi falls under the category of SBC or SBC or Single Board Computer. It is not just a microcontroller, but a full-fledged computer on a single board. Raspberry Pi boards typically include a microprocessor, memory, input and output ports, and the capability to run a variety of operating systems. They are versatile and used for a wide range of applications, including desktop computing, media centers, and as a platform for learning programming and electronics. So, thank you very much.